A plate 0.025 mm distance from a fixed plate moves at 60 cm and requires a force of 2 Newton per unit area, i.e. 2 Newton per meter square to maintain this speed. Determine the fluid viscosity, which is mu, between the plates. So first of all, we have to understand the question, what is the question, and what we have to find. So the question is that one plate is there, and two plate is there. One is fixed plate and the other is movable plate. And the distance between the two plate is 0.025 mm. Distance between the two plates, and the top plate, which is a movable plate, moves at a 60 centimeter per second and requires a force of 2 Newton per unit area. Okay, so top plate is moving at a 60 centimeter per second. I have drawn these two plates for the understanding purpose. 1 mm is and this much, and 0.025 mm is this much. So we have to determine the fluid viscosity, which is mu, between the two plates. Okay, so this is the two plates, and the fluid viscosity, which is mu, we have to find. Okay, so we have to come to the solution. First of all, want to explain like that what mm, the difference between the mm. 25 meter is 25,000 mm, 1 meter is 1000 mm, 0.5 meter is 500 mm, 0.1 meter is 100 mm, and 0.01 meter is 10 mm. Okay, so here's the distance between the two plates. It's very thin. It's 0.025 mm. It's not 1 mm. It is less than 1 mm. So this is 0.025 mm. Okay, this is fixed plate and this is top is movable plate. So given distance between the two plates 0.025 mm. Okay, so we have to convert this in meter. So we have to divide this by 1000. So 0.025 into 10 is to minus 3 meter. Okay. To convert mm to meter, we have to divide this by 1000. Okay. We have got this 0.025 multiplied by 10 raised to minus 3 meter. Velocity of upper plate. Okay, so this is the top plate which is moving. The upper plate velocity is 60 centimeter per second. So it is denoted by u. Okay, velocity 60 centimeter per second, but we have to convert this in meter per second. So we have to divide 60 by 100 to convert in meter per second. So this is 0.6 meter per second. Force on the upper plate is equal to 2 Newton per meter square torque. This is the shear stress. So in the question it is like it is moving at a 60 centimeter per second, requires a force of 2 Newton per unit area. So this 2 Newton per meter square, it's a shear stress. Okay, it's a shear stress. So in the above equation, this is the equation. Okay, so from the equation we have shear stress is equal to mu du by dy. Okay, du means change in velocity and y is change in distance. Okay, du is equal to change in velocity, dy is change in distance, and this is the shear stress force per unit area. So this all is given in the question. So we have to apply the equation shear stress is equal to mu du by dy. Okay, du by dy. So shear stress which is 2 Newton per meter per meter square. Okay, mu we have to find this viscosity, fluid viscosity, and du is the velocity in meter per second. Okay, 0.6 meter per second. From the question we have got. Okay, and dy is the change in distance, 0.025 into 10 is to minus 3. Okay, so as per 0.6 will come down, and this all the term will come up. Okay, as per mathematical rules, we have got this. So we have to write like this. Okay, here mu is equal to 0 into 0.5 into we have to this we have to enter this in the calculator. Okay, like this. So we will get this. Okay, 0.000833333. Okay, and after this we have to reduce all the zero. At least one digit we should have above the point. So we have to multiply by 1 lakh. Okay, so 8.33 into 10 raised to minus 5 Newton second per meter square we have. Now here 1 Newton second per meter square is equal to 10 poise. Okay, 10 poise. 10 poise I will explain in the new lecture. Therefore mu is equal to 8.33 into 10 raised to minus 5, and in place of Newton this, and in place of this we have got this as 1 Newton second per meter square is equal to 10 raised to 1 poise. Okay, so after the calculation the final answer is mu is equal to 8.33 into 10 raised to minus 4 poise. Okay, and the last is fluid viscosity is 3 into 10 raised to minus 4 poise.